right? So let us see types of binary trees. So the first type of binary tree is strictly binary tree, full binary tree, or proper binary tree. So what is the definition? A binary tree having 2 raised to I nodes in any given level I is called as a strictly binary tree. That means given any level I, it will be having 2 raised to I nodes. It will be having 2 raised to I nodes. Say for example, this is one of the strictly binary tree. So its level is 0. So how many nodes it is having? 1. So that is nothing but 2 raised to I. That is nothing but 2 raised to 0 because I is 0. So 2 raised to 0 is 1. So it is having 1 node. It is having 1 node. Next coming to next level. How many nodes are there? 2 nodes are there. 2 nodes are present. But what is the level 1? So that is 2 raised to 1. Because what is the formula? 2 raised to I, 2 raised to 1, that is equal to 2. At this level, how many nodes we have? 1 and 2. So coming to level 2. So 2 raised to 2 is how much? 4. So at this level, we should have 4 nodes. 1, 2, 3, 4. So this is what is simple notation for the strictly binary tree. What it says, at any given level, we should have maximum 2 raised to I nodes. It will be having 2 raised to I nodes. That is what is strictly binary tree. So that's what is strictly binary tree. So let us see the next type, that is skewed tree. So what is skewed tree? A tree consisting of only either left subtree or only right subtree. That is called as a skewed binary tree. That is called as skewed binary tree. That means slant binary tree. You can also call it as slant binary tree or oriented towards any one side. So that is called as skewed binary tree. For example, a tree with only left subtree is called as left skewed binary tree. In that tree, only left subtree is there. There is no right subtree. That is called as left skewed binary tree. And in a binary tree, if we have only right subtree and there is no left subtree, that is called as right skewed binary tree. So two types, left skewed binary tree and another one is right skewed binary tree. So what they indicate, trees having only left subtree and trees having only right subtree. So this diagram will help us to understand. This is what is right skewed binary tree. For this one node we have right subtree. Again we have right subtree. So if you want to extend this, it is possible to only have right subtree. 5, 8, 9. You can extend only in this way, only towards right side. There is no left child. There is no left child anywhere. So then it is called as right skewed binary tree. Coming to left skewed binary tree, a binary tree having only left subtrees. See if you can imagine here, if you can see here, only left subtrees are available. You can extend it only in this direction. You are not supposed to write like this. Why? Because it is a left skewed binary tree. What is left skewed? A binary tree having only left subtrees. Right skewed, a binary tree having only right subtrees. So this is what is the example for skewed binary trees. What is a complete binary tree? Complete binary tree is a binary tree in which at every level except possibly the last level is completely filled. So I'll explain it once again. What is complete binary tree? It is also a binary tree, but in which every level is completely filled, but except the last level. Last level may not be filled. That means all the children may not be present in the last level. If the nodes in the last level are not completely filled, so there is one condition. Every level must be completely filled except the last level. But in the last level, if the nodes are not completely filled, then there is one condition. What is that? Then all the nodes in that level should be filled only from left to right. All the nodes should be only filled from left to right. Then it is called as a complete binary tree. So for example, every node is completely filled except the last level. This is level 0, this is level 1 and this is level 2. What it says, complete binary tree, every level except possibly the last level is completely filled. Every level must be completely filled. That means every level should have 2 raised to I nodes. Every level should have 2 raised to I nodes. That means parents should have equal maximum 2 children completely. That means one, this is complete binary, this is complete binary tree. This is also a complete binary tree. Why? Because last level there must be 2 raised to I nodes. Level is 2. So there should be 4 nodes here. Actually to complete this tree, you should have something like this. Then it becomes complete binary tree. But there is a condition. What is that? What is that condition? If then all the nodes in that level, sorry, if the nodes in the last level are not completely filled, then all the nodes in that level should be filled only from left to right. So we have started filling from left to right. So then it is complete binary tree. If you write like this, then also it is complete binary tree. See this example. This is also a complete binary tree because last level, even if all the nodes are not there, we have started filling it from left to right. Again, this is complete binary tree because we have started filling nodes from first complete the left subtree, right subtree of this node, then left subtree. This is also complete binary tree. If you write like this, then also it becomes a complete binary tree. What are the examples for not complete binary tree? It is not a complete binary tree. Why? Because property what it says, every level must be completely filled. So it is completely filled. This level 0 is completely filled. Level 1 is also completely filled. Coming to level 2, it is not completely filled. Why? Because if you write something like this, then it will become completely filled binary tree. But for filling this, what is that condition? They must be filled from left to right. First you should fill this left subtree. Then only you are allowed to go to this right subtree. But what we are trying to do here is, in this case, there is no left subtree for 5. There is no left subtree for 5. But without this left subtree, we are trying to fill the right subtree with 4. Then it becomes, it is not a complete binary tree. It is a binary tree, but it is not a complete binary tree. Because completion of nodes must take place from left to right. Coming to this example, it is also a binary tree, but it is not a complete binary tree. Why? Because nodes are filled completely here, nodes are completely filled, but here nodes are not filled. But here nodes are not filled. What is that condition? If nodes are not filled at the last level, they must be filled from left to right. That means for 5, 7 left subtree is present, but for 5 right subtree is not there. Then similarly for 6 we have left subtree. It is not a complete binary tree. To make it complete binary tree, what changes we should do in this? You should take a right subtree here and fill it. Now it becomes complete binary tree. Why? Because the nodes are getting filled from left to right. The nodes are getting filled from left to right. Now it becomes complete binary tree. But if you remove this, it is not a complete binary tree. It is not a complete binary tree. So these were the 3 types of binary trees.